2. In this section, we'll be looking at comparing population means dependent samples using matched pairs data. So what we do here is we find the difference between matched pairs data values by literally subtracting them, and the calculator will do that for us. And then we find the mean of the differences and compare those differences to 0. Because if the values were equal, their difference would be 0. So let's take a look at an example. In an experiment conducted online at the University of Mississippi, study participants are asked to react to a stimulus. In one experiment, the participant must press a key on seeing a blue screen. Reaction time in seconds to press the key is measured. The same person is then asked to press a key on seeing a red screen, again with reaction time measured. The results for 6 randomly sampled study participants are as follows. Is the reaction time to the blue stimulus slower than the reaction time to the red stimulus at the alpha equals 0.1 level of significance? Note, a normal probability plot indicates that the differences are normally distributed. Okay, so a couple things. We are looking at slower. So sometimes it can be a little bit tricky to determine the hypotheses here. Well, not the null hypothesis. The null hypothesis will pretty much be the same every time. And that is that the mean of the differences is 0, meaning there's no difference, that they would react in the same amount of time to a blue or a red stimulus. So now the question is, for our alternative hypothesis, what inequality symbol do we use? Well, it's asking if the reaction time to the blue stimulus is slower. So let's just take a look at one of the participants where that is the case. Participant 1 had a slower reaction time to the blue stimulus. They reacted in 0.582 seconds to blue and 0.408 seconds to red. So one thing to keep in mind is that we'll be subtracting these values, and we do subtract those values, we get a positive number. That kind of gives us a hint that our alternative hypothesis should be a greater than 0 hypothesis. I'm also going to show you how to kind of check that in your lists and in your summary after you do your stat test. So what we have to do is type in the blue times into list 1 and the red times into list 2. And then we'll eventually use list 3 to record the differences. So we'll go to our stat edit menu and let's type in the blue reaction times into list 1. So 0.582, 0.481, 0.841, 0.267, 0.685, and 0.450. So now I'm going to list 2 to type in the red times. Make sure you keep them in the same order because these data are matched pairs, meaning they literally match up with each other. So 0.408, 0.407, 0.542, 0.402, 0.456, and 0.533. Now we want to find the differences between these matched pairs data. So you need to go to L3, arrow all the way to the top, and press enter. You'll see that it's blinking down here. This means you can define L3 with a function that it can basically do the subtraction for us. So I'm going to do L1, so second, number 1, minus L2, second, 2. And then when you press enter, it's going to populate list 3 with the differences. So notice that for the majority of these, there are positive numbers, meaning most people were slower to the blue light than the red light, probably because people associate red with danger or emergencies. Not everyone. A couple people have a negative value, meaning they were a little bit slower for red. But for the most part, people were reacting slower to blue, meaning they had a higher value, a higher time for blue than for red. So that's just a way to double check that I'm good with my alternative hypothesis, which is that the mean differences are positive. Okay. Now that we have L3 populated, we can go ahead and do our stat test. So we're going to go to stat, tests, and we're going to do a t-test. We only have one parameter here, right? So we can just do a plain t-test like we did back in chapter 10.3. And we will be using data because we used a list. We'll change it to list 3 in a second. Mu naught is the mean in our hypothesis, which is 0. The list we used was actually L3. We always want to use the list where we have the differences. And then we'll choose our alternative, which is a greater than hypothesis. And then when we go to calculate, it will give us our p-value. Okay, so our p-value is 0.123, so let's write that down. P is approximately equal to 0.123. I also want to point out one other thing while we're looking at this screen, and that is X bar. In this context, this is actually called D bar, the sample mean differences. Notice that the sample mean differences are a positive number. This is just another way to check that my alternative hypothesis is correct. Remember that your sample evidence should support H1, and it does because this number here is greater than 0. So this is a kind of a way to triple check that your H1 is the correct hypothesis. Okay, so our p-value is 0.123. Our significance level was 0.1. So this means that p is greater than alpha, which means our sample evidence is not considered statistically significant. So part C says, do you reject H0? The answer is no, because p is greater than alpha. So we can write a conclusion. There is not sufficient evidence to conclude that people react more slowly to a blue stimulus than a red one. Okay, so let's try another one and just see how it's different and also see the similarities. The following data represent the cost of a one-night stay in Hampton Inn Hotels and La Quinta Inn Hotels for a random sample of 10 cities. Test the claim that Hampton Inn Hotels are priced differently than La Quinta Inn Hotels at the alpha equals 0.05 level of significance. Note, a normal probability plot indicates that the differences are normally distributed. That's always added in when our sample sizes are small, just to know that we can use a test that our requirements are met. Okay, so this one, a word is jumping out to me. That word is differently. This is giving us the hint for our alternative hypothesis. Our null hypothesis will always be the same, that the population mean differences are 0. Meaning if you subtracted, you get 0. So we would say the prices are the same for the hotels. The alternative is that the prices are different. So this alternative hypothesis will be that mu d is not equal to 0. So let's go ahead and type in the prices into our lists. And I'm going to just type over what I have here. So I'll put the Hampton Inn prices in list 1, 129, 149, 149, 189, 109, 160, 149, 129, 129, 119. Okay, same for list 2. Let's go all the way back to the top. Oops. I'll put the La Quinta Inn Hotels in here. 105, 96, 49, 149, 119, 89, 72, 59, 90, 69. Okay, and then we want to put the differences in list 3. So we have to go all the way up to the top of list 3, press enter. Now we can define list 3. I'm going to clear out what's in there and type in second L1 minus second 2, list 2. So now it's going to just recompute the differences between the corresponding values in list 1 and list 2 for us. Okay, so now we have the differences in here. Notice that most of them are positive because for the most part the Hampton Inn was more expensive, except in one city. What city was that? San Diego, for some reason. Okay, so now that we have list 3 complete, we can go to our stat, tests, t-test. Okay, so all of this is the same as last time. Mu naught is 0. The list is list 3. we do need to change the alternative hypothesis to be a two-tailed test, a not equal to hypothesis. Then go down to calculate and press enter. And here we have a p-value. Now, it looks like p is 5.128. But remember that the p-value is a probability, meaning it has to be between 0 and 1. So the probability cannot be 5. So if I keep on reading, I'm going to notice that this is in scientific notation. Okay? So that means I'm going to move the decimal 4 places to the left. So the p-value is actually about 0.0005, which is a very, very low p-value. It's certainly lower than the level of significance, which is given as 0.05. So p is less than alpha, so this means that we will reject H naught. So let's write out a conclusion. We have sufficient evidence to conclude that Hampton Inn and La Quinta Inn hotels are priced differently. And I also wanted to let you know that this problem is very similar to how you'll be doing project 2. So I'm going to put a note here. You will be doing price comparisons for your second project. So it's going to be a similar structure as this. So you might want to use this as a guide to help you when you are setting up your project 2.